Today we will be seeing the through input of three models according to the assignment. The buffer capacity combination that I choose is 686. But first, we will try out the status plot for model A. As you can see here, the red is for when the process is running, the green is when the parts are blocked, and the blue is when the machine is starved. Here the process goes. As we can see, there was the beginning and the start is rise up, but then it started to stabilize as the process went on. Let's try it with model B as well. But as we can see, a similar story happened where it goes up and then suddenly starts stabilizing. And then we try model C. You can see here in model C that that it boots up a bit longer but stabilizes quite fast. Anyway, now we will see the true input as well as the blocked time. Yep, this is the time block and time processing of M1 in minutes. This is the time block time processing and time start of M2 in minutes. This is time start of M3, time block processing of M3 and time start of M3 in minutes. This is the time processing and time start of M4 in minutes. This is the time processing and time block of M1 in model B in minutes. This is the time start, time processing and time block of M2 in model B in minutes. This is the time start and time processing of M3 in model B in minutes. Notably, there is no time blocked. And in M4, there is this time start and time processing of model P in minutes. And in model C, this is the time block and time processing of its M1. This is the time block, time processing, and time start of its M2. This is the time block, time processing, and time start of its M3. And this is the time processing and time start of its M4. Now we will try an experiment. So we see its throughput. Let's run this experiment. Let's modify this thing. We will run it for 125 hours, and the warm-up period will be 25 hours. Run this again with updated settings. As we can see, the the machine utilization of M1 is this, machine utilization of M2 is this, the machine utilization of M3 is this, the machine utilization of M4 is this, the number system is 15.4, the timing system is The time system is 20 minutes, and the through input is 44.85. We will do the same in Model P. When with car count, the warm-up period will be 25 hours, and the required application will be 10. We can see the through input is 59.435. The machine utilization of 1, 2, 3, 4, they're very high, and the number in system is 14.3, while the time system is 14.4. We will do the same with Model 3. And as we can see here, number system is 16.2, time system 26 minutes. The machine utilization is in the 92%, but which is lower than in Model P, and the through input is 37.151. If you look at Model B, you can see that the schedule utilization is 99% for all machines. And this would mean that the buffer distribution is near perfect for this model. However, if you look at Model C, the schedule utilization is only 92%. And we can fix this by looking at the time percentages of time start and time blocked. Here you can see that M4 has a very high percentage of time start paired together. Well, you can hear that the M2 and the M3, well, M2 and M1 have a very high time block percentage. That means some of the buffer that could go between M3 and M4 could be redistributed to between M1 and M2 and M2 and M3. You can do the same here in Model A, where you can also redistribute the buffer between M3 and M4, which here has creates a very high percentage of time start. You can also redistribute for the buffer between M1 and M2 and M2 and M3, which has a very high percentage of time blocked. In conclusion, Model A needs more buffer capacity in buffer 2 and buffer 3 and less buffer capacity in buffer 4. Model B is near perfect and shouldn't really be messed with. And buffer C also needs more buffer capacity in buffer 2 and buffer 3 and less buffer capacity in buffer 4, although it might not be as extreme as in Model A.